Okay, inverse circular functions, where the fun begins. I kind of make lazy notes. We're gonna roll with the lazy notes. So up first, we're gonna recall that every element in X, for a function, every element in X, the domain corresponds to only to one and only one element of Y, right? That's saying that our X's don't repeat, correct? There's an input and an output. So if a function is defined so that each range element is used only once, then it's called a one-to-one function. Do you remember that? It passes the horizontal line test and the vertical line test, right? Not only do your X's not repeat, but so do your Y's, right? They do not repeat as well. So inverse function. So an inverse function comes from when you have a one-to-one function. Does that ring a bell from college algebra? It can only be an inverse function if the original function is one-to-one. So the original function, there's no repeating X's and no repeating Y's, then there's an inverse that exists. Does that ring some bells? Yeah? One-to-one? Okay. This is just definition and vocabulary review. You don't have to write it down. It doesn't pertain to anything right now. All right. The -1 is not an exponent. It does not mean put it in the denominator, okay? It stands for inverse of a function. So when you see f to the -1 of x, it does not mean 1 over f of x. It's a sad misconception that rolls over from your exponent rules, okay? It just stands for this is the inverse of a function. My x's and y's were switched and I resolved for y, okay? That's what that is telling you. All right, so making sure we're good with inverse functions. 1-to-1, each x value corresponds to only one y value, and each y value corresponds to only one x value. No repeating x's, no repeating y's, right? When we write it using f to the -1, and that only happens if the original function is 1-to-1. Okay, the domain and range of the inverse is the opposite of the original. Does that make sense? Because if my x's and y's are switching, that means that my domain and my range are switching. Yes? Okay. And then there's always going to be the reflection. So when you look at it graphically, remember it's reflecting over the y equals x line. All right, so this is our quick algebra review about inverse functions. Do we remember vaguely or for sure this information about inverse functions from algebra? Okay. Well, I don't think we're going to. So to solve, remember we would switch our x and our y and use inverse operations to solve for y again. Y'all remember doing that? Yes? No one's like, I've never done that, lady. Okay. I know for a fact that you all have, because I was your teacher then. So, and then once you get y by itself, you replace it with the inverse function. So, okay. So, yes, we're good here. All in our brain, somewhere in a file cabinet. Oh, this is review from algebra. Yeah, just making sure we're there. So visually, what we look at, when we are looking, your y equals x line is that invisible line that goes through the origin. If you have inverse functions, remember they're going to be reflection over the y equals x line. Yes? Y'all remember seeing something like this? Okay. To find the inverse function, that's where we would have taken our y and our x and switched them, and then that's how we end up with our inverse. I knew that there was an inverse with no restrictions because when I look at the original function, the blue function, it is 1-to-1. Meaning that the blue function passes the horizontal and vertical line test, correct? No repeating x's, no repeating y's. To find the inverse, we switched our x and y. So it became x equal y cubed minus 1. And then we did inverse operations to get y by itself. So we had x plus 1, and then we took the cube root. And that got y by itself, which now made it our inverse. Yes? Remembering? All good? All right, perfect. Now, how does that work with trig? That is the question, okay? Trig inverse is called either inverse or arc. So if I have either y equals inverse sine or y equals arc sine, okay? Depending on the book, the text, your research, what you're looking up, it's going to be written in those two ways. So either you're using inverse sine or you're using arc sine. Basically, what that means is that you switched your x and your y. Do we see that? So that means we've switched the x and the y. Okay. And so for our domain, it's restricted. It's only between, our range is restricted. It's negative pi over 2 to positive pi over 2. So what we're thinking is, why is the number, the angle in the interval, whose sine is this? Okay. So you're going backwards. You have the value of your sine. You have your angle, no, the value of it, and you're trying to figure out what angle made it. Who did it? Where'd you come from? But just making sure we're comfortable with how it would look. So you're either going to see it as y inverse of sine or y arc sine. They mean the exact same thing. Okay. All right. So starting off here, it says we have y equals arc sine 1/2. So we're asking ourselves, for what theta do I get 1/2? Sine equals 1/2. So you're thinking sine of what theta equals 1/2. That's what you're asking yourself. So where else? Where else do I get a positive 1/2? Sine is positive in quadrant 1 and quadrant 2. There we go. So when you look at arc sine, it's asking you for what theta makes this true. Does that make sense? Oh, I didn't mean it right there. Okay, so we know that it's asking when does this happen, and it's saying from negative pi over 2 to positive pi over 2. And we know that we get 1/2 when it's at 30 degrees. 30 degrees is the same thing as pi over 6. So we set 30 degrees, which equals pi over 6. It just depends on what it's asking you. If it says on the assignment radian value or degree value, you just need to be comfortable going in between. It says find y. Yeah, so this one didn't specify. But I'm saying you need, yeah. Okay, so our answer would be pi over 6. Does that make sense? We wouldn't use the 150 because does it fit in this interval? No. Okay, are you ready to try again? Huh? Yeah. Okay, so this is what it's asking. So when we graph it, we'd be able to find. All right, ready again? So now it's saying sine inverse of -1. So this time we're asking ourselves, when does sine theta equal -1? When sine is what? Oh, at 270 or 3 pi over 2, right? Now, the problem is, if they gave us this restriction, would that fit in there? Well, it'll be from, well, is that what that means? It'll work. You put negative pi over 2. 3 pi over 2 is the same thing as negative pi over 2. If I was to go the other way, I see. 3 pi over 2 is the same thing as negative pi over 2, right? 3 pi, yeah, we agree? So the answer would be negative pi over 2. Yep. Because you went clockwise instead of counterclockwise. So if we were going our counterclockwise, this would be 3 pi over 2, right? And when you're going clockwise, this makes it negative pi over 2. So this is our positive angle. This is our negative angle. Because it says that we have to be between negative pi over 2 and pi over 2. And 3 pi over 2 is it doesn't fit in that range. Does 3 pi over 2 fit in that range? No, but does negative pi over 2? Yeah. I mean, like, I get it. I just don't want to. Why does it equal that? Because they're coterminal angles. Oh, it's like they're coterminal angles. Yeah, I get how you got it. I don't really see the difference. Because they gave me a restriction. It says your y has to be between negative pi over 2 and positive pi over 2. So that means it's either pi over 2? It means that I can be any number between negative pi over 2 and positive pi over 2. So think of it in terms of degrees. I could be anywhere from negative 90 to positive 90. And 270 does not fall between that, does it? So therefore, I have to put it in terms of something that falls in between. Looking at it on a graph, this is what it would look like. Will we have to graph? Yeah. Like the function, yes. But like the function and analyze it, like the domain, the range, yeah. Just like we did with sine, cosine, tangent, cosecant, secant. All right. Now, what happens when we start getting to values that are not on our unit circle? We do not shut down. We do not shut down. So we have y sine inverse of -2. So this is what happens. -2 is not in the domain of the inverse. It's not in there. So our domain of our inverse function is from -1 to 1. Does -2 fall in there? No. So guess what that means? No solution. It does not exist. And if you were to type it in the calculator, it's going to give you a error. Okay? You're like, man, what did I do wrong? If it's on the calculator part of the test. Okay? Now, reason why that's my domain is that, remember, when you switched your domain and range, your inverse. So what was our range for the sine function? What is our max and our min on our sine function? -1 to 1, right? If I'm now switching, that's now my domain for my inverse. And so that's why our values can't be higher than -1 and 1.
So instead of going this way, it goes this way?
Mm-hmm. It's the weird, it goes like this. Have you not, that guy? It's like this. That's the inverse of sine. Okay, so make sure that it's in the range. So if you see a number that's outside of that range of -1 to 1, then that tells you it is not possible. It's not that. It's not. All right, so let's talk about the function. So here's the function. We're going to talk about our domain and our range. Here are your parent function values and the image of the graph. We're going to go to Sylvie. I had to close her out earlier. I apologize. She's back. Don't worry. There she is in all of her glory. So here's Sylvie. If I go over here and I'm going to graph the inverse. So you see how it's right above sine. I'm going to press second, sine, x. I don't really need close parentheses. I'm going to hit graph. And it looks like it's a horizontal line, right? I made a straight line. Vertical as a horizontal. It is not. So if we do zoom, trig, it'll try to move in a little bit better. It's only in that spot. That's it. It's in that spot only. Okay. I can zoom in better, but it's not working. That's why we emphasize making sure you understand it's only from -1 to 1. So I can go to the window and I'm going to knock it down to -2 to +1. And we'll just count by 1. And then my range, if you want to go higher than pi over 2, you can do 2 pi. There's really no purpose. It just gives you a better window, but this should be good enough. Now when we hit graph, you can kind of see that it's curving more. Not negative, +2. Oh, I did 1. And then on your max and min, it doesn't really matter. But so you can kind of see that it's curving, not, you see it's curved now, not that it's a straight line. Yes, I can. I can get rid of Sylvia altogether. Okay, so when we're looking at this, notice that the angles that we typically use are the values that we typically use are -1, -√2/2, 0, √2/2, and 1. They just give us friendlier numbers. Obviously, there are other values in between, but we have our half, our quarter, our -1/2, and our -1/4 of pi. Okay, so what does this mean in terms of finding the sign of something? You're gonna have to use your coterminal angles. So if you're given 360, you wouldn't put 360 in, right? You would have to use its coterminal, which is 0. Does that make sense? Yes, makes sense. If I was given 240, I wouldn't be able to use 240. I would have to subtract 360 and use its coterminal angle. Yeah, you with me? Okay, so again, if it helps you, think about everything in terms of this is 90, -90, this is +90, right? If that helps you. But you have to be in between those two, which is why you have to use your coterminal angles. Okay,
So you absolutely.
you have to be between those two, or you're going to get an error when you're inputting into the calculator. Okay. Okay. Yes. All right. Okay. The inverse function, as you can see, is increasing continuously from -1 to 1. Did we notice that? Yes. It has an x-intercept and y-intercept at the origin. And the graph is symmetrical, meaning that it's rotational symmetry. And therefore it's an odd function. Odd function means I go through the origin, and if I was to rotate it 180 degrees, it would look the same. And those are our 3 main features of our sine inverse, which are things that hopefully you can identify yourself by looking at the graph. Yes? Do we feel confident in those 3 things being something you like, oh, I knew that just by looking at the graph? All right, now we're going to talk about the cosine. So cosine inverse, again, remember it can either be written as cosine inverse or arc. So you're either going to have inverse or arc cosine. And you're asking yourself for what value gives you, what value of y gives you x, your degree. Now, its range here is 0 to pi. So we're looking in quadrants 1 and quadrants 2. Okay. Has anyone caught on to why 0 to pi? What's the value of cosine for 0 and pi? 1 and -1. And what is our range restriction? How high does our cosine graph go? And how low does it go? Our cosine can only go up as high as 1 and low as -1. And that's my range of cosine, right? When I do the inverse, that range now becomes my domain. So my domain is 1 to -1 to 1. And the only way I can get -1 to 1 is if I'm from 0 to pi. That's the values when cosine is -1. So for sine, it was the other way around, right? When did sine equal 1 or -1? It was at pi over 2 and -pi over 2. Do you see that? That's why it's your restriction. Okay, does that, are we making that connection?
And for this, it's still counterclockwise and for sine,
It's always counterclockwise unless you need to find a coterminal to make it fit in between. Okay. So again, just so we can see it visually. So at 0, we're 1 comma, this is our 0 value, right? At pi, we are -1 comma 0. When we switch our inverse, that means your X and your Y are switching roles, essentially, when you're solving. So now it's saying instead of our graph being from, what is it? Our cup going up to 1 and down to -1, those are now our X values, right? We start at -1 and we end at +1. And the only things that we can equal are between 0 and pi, because that's where that restriction lies. So for example, starting off simple, we're asking y equals arc cosine 1. So in our heads, we're asking ourselves for what cosine theta gives me 1. And the answer is 0. No. Okay, and does 0 fall at, we gotta remember that our theta has to be between 0 and pi. Does 0 fall between 0 and pi? Yes. Make sense? Okay, so the cosine inverse is just the opposite of the sine, except it doesn't go through the origin. So when I'm at 1, I am at 0. It's not that bad.
So yes. You said 43. Yeah, 43 slides. No, we're on 16. But that is. Has to, it's gonna go back through, said, maybe it's not, like.
All right, are you ready to try again? Cosine inverse of -√2 over 2. So I'm asking myself for what cosine theta equals -√2 over 2.
Okay.
I need one between 0 and pi. What'd you say? What is that in radians? Okay, we need to be negative cosine, right? Which means that we are in quadrant 2 or 3. We can't use 3, can we? No, so it has to be in 2, which puts us at 3 pi over 4. Got it? Yeah. But you're getting there, right? We're catching on. Okay, so when you look at it on the calculator, it'll say all the decimals, but your exact answer is 3 pi over 4. Bless you, bless you, bless you.
Why?
All right.
Why is y 3 pi over 4?
Because you're asking yourself for what theta gives me -√2 over 2.
Right.
So it has to be in quadrant 2, right? And in quadrant 2, when do I get x equals -√2 over 2?
Yeah. 1/3.
Which is what?
Oh, so y equals. Oh.
Yes. All right. So here is the cosine function. The cosine function looks like this. You are dividing from 0 to pi into quarters. So you have 1 quarter, 2 quarter, 3 quarter, and then 4 quarters.
So for cosine, you know, I use quad 1 and 2
Mhm.
for sine, is it just quad 1 or is it just that half?
Sine is 2 and 3.
So what is that? If the other one was negative 90 to 90, this was what? Negative 90 to 90?
Wait, sine's 2 and
So
3?
sorry, 1 and 4.
Okay.
I was like, what did I just tell you? I had to finish processing what I told Lupe. Sine is quadrants 1 and 4. Now, what were you saying?
If the last one was negative 90 to 90, was this?
This one is 0 to 180, 0 to pi.
Oh, okay.
Yeah.
Is it 0?
It's 0 to pi, 0. No, just negative 180 and positive 180 are the same. It's at the same stopping point.
I thought if this is possible.
It's the same line. 0 and 180 don't move.
Oh.
No. Not in this case. All right. Yes. All right.
Oh, don't move it yet.
Don't move it yet? Okay. Okay, so again, for your table, it's in the, you're dividing quadrants 1 and 2 into quarters. Do we see that? And we're using your cosine value for your 3 pi's over 4. Which thankfully are the same as your sine values. So just gotta pay attention to the sign. There's never gonna do tangent.
The second question.
Yeah, it's part of it.
Yeah, let me just take a picture.
Oh, you're cool.
I just need to grab. That's it.
Okay, so takeaways from this graph, we should see that it is a decreasing function. Did we see that it was continuously decreasing? Yes, on the interval from -1 to 1. You should see that your x-intercept is 1. And its y-intercept is at pi over 2. Those are things that we should have taken away from the graph. The graph is not symmetrical with respect to the y-axis nor the origin. There's no symmetry in cosine. Yeah, there's no symmetry in cosine. So those are the 3 things you should have been able to analyze from looking at that graph. Yes? Okay. Questions, comments, or concerns about inverse cosine? All right. Up next is inverse tan. So for tan, so remember tan was our guy with the asymptotes, right? Those boundaries. It no longer has vertical asymptotes. It now has horizontal asymptotes because the inverse of vertical is horizontal. So it now has horizontal asymptotes, and its horizontal asymptotes are at -pi/2 and pi/2, which means that it's not equal there, right? I can get as close as I want to -90 and to +90, but I cannot actually touch it equally. Okay, and why is that? Anyone? Let's take a stab as to why.
Wait, what'd you say?
Why can't I equal or touch -90?
Who's the asymptote?
The asymptotes, but what would be like a reason? What are your values? What is cosine? It would be, if the inverse of it would make it, yeah, it would be the zeros is where you get your 0 values at. So at negative, because it's 0, right, y over x, right? That's where you have your 0 values at. Exactly. That's where your asymptotes.
Oh,
So it was negative.
The domain is, yeah.
Yeah, that's why.
Yeah, you could use any value. So theta is free game.
so
I
there's
mean, my output is free game, not my theta.
So there's no quadrant in between all quadrants?
It's still 1 and 2. I meant 1 and 4, because it says it just can't equal 1 and 4. Like you can't equal 90 anymore. Like with sine, you can equal 90, right? I could take the sine of 90. I could take the cosine of 90. Well, the inverse sine of 90, the inverse cosine of 90. I can't do that with tan.
Okay, so what do you do?
You'll just say undefined.
Oh,
Because there's what there now? What's at 90 now?
10 always undefined.
Pi over 2, and there's,
Is 10 always undefined?
for 10 inverse is undefined for negative pi over 2 and pi over 2, because you have what there? Horizontal asymptotes. Horizontal.
Are these always gonna be the main for?
The parent functions, yes. Functions move though. These are your parent functions for the inverse. So this is where it starts. Okay, what can we analyze from this graph? We're increasing, our x and y intercept is at 0. And what type of symmetry? Rotational origin symmetry. I don't know where she was going. So therefore it has, it's an odd function. It has origin symmetry, aka rotational symmetry, which makes it an odd function. Okay, so those are things you should be able to analyze. Next is that there are horizontal asymptotes, right? The other two things that you have horizontal asymptotes, which means that your y has a boundary. You can touch me, but you'll never equal me. But you can't touch me. Okay. All right, cotangent.
There's more.
We have to learn all of them.
We got
They're coming. We're gonna do it all together.
I haven't even finished 10 yet.
Okay, cotangent. So the cotangent inverse is that from negative to infinity. However, there is two horizontal asymptotes, one at 0 and one at pi. Mhm. Yep. Because that's where 0 to pi. All right. So this time again, your horizontal asymptotes are at 0 and pi.
Wait, what'd you say?
Your horizontal asymptotes are at 0 and pi. See.
So for like, except for sine. cosine, would it all have asymptotes?
Yes. Wait, no,
This, it went this way now.
we shouldn't on the next one. It's a one asymptote.
Yeah. No, cosine.
Sine and cos, secant and cosecant
Tangent
only
went
have
this
one.
way, because the tangent went this way.
That's what I'm saying.
No.
The main thing is knowing your domain and knowing your range.
Right. Expands?
Yeah.
All right, so this graph from left to right, what is it doing? Decreasing. What are its asymptotes?
0 and, what's that?
So it has one asymptote at pi over 2. Between 0 and pi, halfway is pi over 2, guys.
Oh, no, you said asymptote.
I said asymptote? I thought I said intercept.
No.
No.
Jesus, take the wheel. If I said asymptotes, you're right. Good job. I meant intercepts. Where are the intercepts? Pi over 2. Good job. Is there any type of symmetry? No, there's not.
Okay, so those are, they still
They're still horizontal asymptotes.
So if they both go this way,
They both are horizontal. What do you mean?
because.
All right, secant. Secant's a little funky. It has one horizontal asymptote. Yeah. Now you know why. You have horizontal asymptote at pi over 2. Okay. And your domain this time is from negative infinity to negative 1, then 1 to infinity. That's because of that asymptote is smack dab in the middle.
What does the U mean?
It stops.
And yeah, it's this and that after a pause.
The is
Why is
That's
it
four.
like Y and the slash parentheses? Like what?
It means y cannot equal pi over 2, and that's because it's a horizontal asymptote. So it's the entire domain except at that one location. That's
I'm gonna post this for sale.
today I will. Okay, we got one left.
On.
We draw the graph.
Okay. What's left? What's left? Cosecant.
Just also
Why do you
Yes.
Write the graphs, like, graphs, does that matter?
I don't know what they need them for. I think it makes them feel better. Yeah, just visual.
now, but we're not going.
Because if all else fails, I can always graph it in the calculator and see what the graph looks like. Okay. So again, asymptote. And then our last but not least is our cosecant. And this time your asymptote, your horizontal asymptote is at 0. At mm-hmm. We're in quadrant 1 and 4.
One and two.
All right, so we have them all. Yay. So excited. Oh, what time is it? I was gonna show you the whole chart.
Picture this first.
That's why I asked, why are y'all writing all the
See, why
things?
did we just do that in the first?
So you could look and analyze, so you knew where we were going.
So glad that I didn't write any of that.
She kept asking what quadrant of the unit circle. I was like, we're gonna get there, but I'm glad you were asking and acknowledging though, Lupe. So proud of you.
So glad that I did.
Okay, so all together, here they are with their domains, their ranges, and the quadrants that you're looking at on your unit circle.
Woo, hallelujah. I did one smart.
I'm gonna just redo you.
Okay. That's why I was trying to go through it a little fast, but you guys kept telling me to wait. So I didn't want to. I didn't want to impede on your learning. Okay. I was trying not to make you rush. Yeah, exactly. Y'all were learning, and I was like, good. But I was gonna give you a summary. We're gonna get there.
Any other time?
All right. So once you know your values, that's the key thing, is that when you're solving, is knowing if it's possible and if it's not. What's going to give you an error, what's not going to give you an error. If it bothers you to see them in radians, you can always go back in and write 90s and 180. But if you're okay with pi over 2 and pi, I would leave it as pi over 2 and pi. Yes.
Do you have a blank circle?
I don't think I have any more out. There's a quiz somewhere. A blank quiz somewhere.
Because I thought we were going to put the unit circle.
Yeah. I figured you needed to know it anyway, so. Here we go. Really quick, America, here's your example for arctan.
Oh, she got a bunch of them, actually. She don't have some, she got a bunch.
Well, you gotta know it anyway. And know how to use it. I'm actually about to leave for a luncheon. I know.
Why is this easy for them?
Who's everybody?
You know, for me.
Like, who's everybody? All right, just really quick though, quick example, arctan 1. So it says theta must be from -90 to 90, right? How our brain goes. But since 1 is positive, theta must be in quadrant 1. So now I'm looking for arctan of 1. So for what value of theta gives me a tangent of 1? The tan theta equals 1 is for what angle?
What, 89?
45.
45. So it'd be 45 degrees. That's all you're doing. Yeah, you're just thinking backwards.
Oh.
Yep. Yep. See, I said, just wait, and I promise I'll make it. Just think backwards.
You know, graphic, the sticky notes?
Yeah.
I'm gonna graph it just